Now let me tell you why we are discussing about simple and compound expression. Okay, why this simple and compound expression is even related to precedence and associativity of the operator. So what happens is, whenever we have a simple expression, then it's very easy to evaluate. Okay, see, 1 plus 2, it's very easy to evaluate. You can directly tell me the answer. 1 plus 2 is going to be what? It is going to be 3. You can easily calculate. Similarly, if I ask you what is, let's say, A into B, then you can easily tell me the answer. But when the expression is a compound expression, then it can get little bit complex, or it can get little bit difficult or tricky to calculate the answer. Okay, now in this case, whatever compound expressions I have written on my screen, that is 1 plus 2 plus 3, these are very simple to calculate. Okay, so you can easily tell me the answer. All the expressions are kind of, I'll say, very easy to calculate. But let me just go to the next part of my whiteboard and let me show you few expressions which are a little bit tricky, and they are compound expressions. Okay, so let me just change my whiteboard and let me show you few expressions which are a little bit tricky to understand or to calculate. Okay, so let's see. All right, so you can see, let's get started with this few examples that I have written on the screen. So I have 3 examples for you. The first example is very simple. Okay, it's the starter one. So let's say I have 3 plus 2. Okay, 3 plus 2 into 6. Okay, so just pause the video for a while and just try to answer this question. What is the answer of this question? 3 plus 2 into 6. Okay, just try to answer this question. So if you are thinking that the answer is going to be 15, okay, so let me just write this answer here. So if you're thinking that answer is 15, so this is one possibility of the answer, that answer can be 15. And the another possibility of the answer is, I'll say, 30. Okay, so there are 2 possible answers. One is 15 and another one is 30. Now, how one expression can have 2 different answers? Obviously, only one out of them is correct. Okay, so not both of them can be correct. Only one among them is correct. But how different people are getting different answers? So let's figure it out. If you're doing something like this, if you're calculating 2 into 6 first, then you will be getting 2 into 6, that is 12, right? And then if you are adding 12 to 3, then you will be getting answer as 15. Okay, so if this is the way that you are following, then the answer that you will be getting is going to be 15, right? But if you are doing something like this, that if you are adding 3 and 2 first, so 3 and 2, when you will add them, they will become 5. And then when you will multiply 5, which is result of 3 plus 2, when you will multiply it by 6, then you will be getting 5 into 6, that is 30, right? So if if you are following way 1, then you will be getting answer as 15. If you are following way 2, then you will be getting answer as 30. Now the main question here is which way is correct, whether the way 1 is correct or way 2 is correct. Okay, so the answer of this question lies in the rules that every language will basically use, and that rules are called as precedence rules of the operators. Okay, now whenever we have a compound expression, so obviously there are going to be multiple operators. Now whenever there are going to be multiple operators, we need some set of rules to decide which operation to evaluate first, or which operation or which sub expression to execute first, and that decision will be taken based on few set of rules which are provided by the programming languages. Okay, so every programming language will have its set of rules for precedence and associativity. Okay, so basically you are going to use some predefined set of rules for the precedence of the operator. Similarly for the associativity. Now see, we are going to come to the associativity part, and I'm going to explain what is the associativity and how it is different from precedence. Okay, but right now we are just discussing about the precedence. So I hope you have got the idea behind what is the precedence or why the precedence is required. So whenever we have a compound expression, and in compound expression there can be multiple operators, so there is going to be a conflict, or there is going to be a involved decision which we need to take as a programmer, that which sub expression to evaluate first, or which part of the expression to evaluate first. And based on that decision, the output will change, right? You have seen it in this example. So if you are evaluating 2 into 6 first, then the answer will be 15. But if you are evaluating 3 plus 2 first, then the answer is going to be 30, right? So So basically you have to follow some set of rules to decide which one part or which part of the expression to evaluate first, and this part or these rules are called as precedence rules of the operators. Okay, see, similar to the precedence rules of the operator in programming languages, we have learned few rules in our basic mathematics as well. Okay, so we all know about the Baud-Morse rules that we study during our mathematics. So those Baud-Morse rules are nothing but the precedence rules which we usually talk about in our programming. Okay, but in programming we have few more operators apart from the normal arithmetic operator that we usually study in our basic mathematics, right? So that's the reason when we come to programming, we can't just rely on the Baud-Morse rule, because in programming we have many more operators, like we have bitwise operator, we have assignment operators, then we also have a few more additional operators like relational and logical operator, which are not usually present in the mathematics, normal mathematics. That's the reason we need to discuss about this topic, that is precedence. Alright, so now I hope that you have now got a basic idea about what is precedence, and then I'm going to tell you what are the rules available in C++ operators for the precedence. Okay, now let's also try to answer next two questions as well. Okay, so it's going to be a little bit interesting. So let's try to answer the next question, question number 2. So the question number 2, or the expression to number 2, is 2 and 3 greater than 1. Okay, so I want its answer. What is going to be the answer of this expression? Again, pause the video for a while and just try to answer this question. Let me see how many of you are giving the correct answer. You just evaluate by yourself, because I have no way of getting know how or what exactly you are answering. Okay, but just see, I mean, are you able to get the correct answer or not? So okay, let me just explain you what can be the two possible answers of this example. So if you are evaluating 2 and 3 first, okay, 2 and 3 first, if you are evaluating this first, then let's see what is going to be the answer. See, this AND is a bitwise AND operator, so we need to convert all these things into binary. Okay, so let's quickly convert 2 into binary. So 2 in binary is 0 1 0. Let's convert 3 in binary. 3 in binary is 0 1 1, and then we have to perform AND operation. So 0 and 0 is going to be 0, 1 and 1 is going to be 1, 0 and 1 is going to be 0. So what is the answer in decimal? The answer in decimal is 2. So the answer of this sub expression is 2. Then 2 greater than 1, this is correct, right? 2 is greater than 1, so the answer of evaluation of this thing will come as 1, because 2 is greater than 1. So relational operator will either give us answer as 0 or 1, right? So if the relation establishes to truthiness, then it will give us 1 as the output, otherwise it will give 0 as the output. So in this case it is going to give us 1 as the output. Now there is another way of evaluating this expression. What is the another way? See, if you evaluate this part first, 3 greater than 1, okay, so what is going to be the answer of 3 greater than 1? The answer of 3 greater than 1 is going to be 1, right? Because 3 is greater than 1, so it is going to give answer as 1. Then we have 2 and 1. Okay, now let's see what is the answer of 2 and 1. So 2 is 0 1 0, 1 is 0 0 1. Okay, and we have to perform AND operation on it. So if we perform AND operation on it, then you can see that the output that we get is 0 and 1 is 0, 1 and 0 is 0, 0 and 0 is 0. So the answer in this case will be 0. See, so we have two possibilities of the answer. The first possibility is 1, the second possibility is 0. So which one among them is correct? So again, we can't tell the correct answer before knowing about the precedence rule. So we need to know what are the precedence rule and which operator is having more precedence. See, the operator which is having more precedence, that operator or that part of the sub expression which is even involving that operator will be evaluated first. Okay, so let's assume that, let's say, greater than operator, if it is having more precedence as compared to bitwise AND operator, so in that case what will happen is greater than expression, which is 3 greater than 1, will be evaluated first, and then AND expression will be evaluated. Okay, so then in that case the valid answer will be 0. And let's say bitwise AND is having more precedence as compared to greater than operator, then in that case the answer is going to be 1. Okay, because 2 and 3, this sub expression will be evaluated first, and then the answer of 2 and 3, which is 2. So 2 greater than 1, this expression will be evaluated later. Okay, so in this way it will work. So I'm going to explain you the precedence table that is available in C++ operators. So I'm going to explain it to you in detail. Okay, so don't worry about that. We are going to see all the precedence rules which are available in C++, or all the precedence rules for all the operators. So don't worry. Okay, it's gonna be interesting. All right, now just try to answer the next question, third expression. Okay, so the third expression, it is saying 3 equal to 3. Okay, or 1 equal to 0 and 2 equal to 2. Okay, now just try to pause the video and just try to answer this question. Just see whether you are getting the correct answer or not. See, I haven't revealed the answer of second expression yet, so I haven't officially told you that what is the correct answer of question number 2 or expression number 2. Similarly, I'm not going to reveal the answer of expression number 3. Okay, so we are first going to see the precedence rule, and then you are going to guess what is the correct answer among these two answers. Okay, so let's try to guess the answer for the third expression as well. So let's say if this expression evaluates like this, let's say, see, in this case we have multiple operators. Okay, so we have equal to operator, then we have or operator, logical or operator, then we have again equal to operator, then we have and operator, then again we have equal to operator. Okay, so there are multiple operators. Let's assume that this expression executes like this. Let's say we have, let's say this part evaluates first, let's say. Okay, so in this case what will happen? So in this case 3 equal to, let's say 3 equal to 3 will evaluate among these expression as well first. So 3 equal to 3 will result in 1, right? Because 3 is equal to 3. Or we have 1 equal to 0. So 1 equal to 0 will result in 0 because 1 is not equal to 0. And 1 or 0 will result in 0. So output of this expression is going to be 0. Okay. Then we have and 2 equal to 2 after this. Now 0 and anything, I mean, doesn't matter what is the second operand, the answer will always going to be 0. Okay, so I will say, let me just erase out this board. So I will say the first possibility of the answer of this sub expression is, I will say 0. Okay, oh my god, what type of pain I have chosen. Let me just erase this. Okay, so the first possibility is 0. Okay, now the second possibility is, let's say the expression evaluates like this. So let's say this part of the expression evaluates first. So in this case 1 equal to 0, this is false, right? So it is 0. Then and, see, and anything, doesn't matter, the answer of this sub expression will always going to be 0. Okay, so this is 0. Then what we are doing is 3 equal to 3, 3 equal to 3 or 0. Now 3 equal to 3 is what? It is 1. Okay, because 3 is equal to 3. So the answer of this thing is going to be 1. 1 or 0, what is the answer? 1 or 0 is 1, right? I hope you remember all these things we have discussed about in this model. So it's not very difficult, or it's not very old that we have studied. We have studied these things in same model. Okay, so I hope you remember how the equality operator are working. So it is basically relational operator, right? Equal to. Then I hope you remember how the logical operator works. So or is a logical operator, right? So 1 or 0 is going to be 1. Okay, so the second possibility of the answer is nothing but 1. Okay, so even this expression has two possibilities, that is 0 and 1. See, some of you may think a little bit differently, or you may try to do this expression in this way. Let's say 3 equal to 3 or 1, and then equal to 0, and then it will become very complex. Okay, so the way basically the expression evaluation works is, the expression is basically divided into tokens, and based on that the expression is evaluated. So let's say if you are considering this sub expression, that is 3 or 1. Okay, so in this case what will happen? 3 or 1 you can consider, but then 3 equal to 3 or 1. So first this part will be evaluated. Let's say answer of this is 1, because 3 is also truthy, 1 is also truthy, so answer of this is going to be 1. Okay, then we have 3 equal to this, that is 1. Then we have 1 and 2 equal to 2. Okay, let's say again in this case, let's say 2 equal to this part gets evaluated. Okay, so see, we are just doing some random things. Okay, so we don't know which part will evaluate first, so we are just trying to find different possibilities of the answers. Okay, so let's say this part evaluates then. So in that case, the answer 2 equal to 0, it is going to be 1, right? Then let's say this part evaluates, so answer of 3 equal to 1, it is going to be 0. And then 0 and 1, what is the answer? 0 and 1 is going to be 1. 0. 0 and 1 is going to be 0. So in this case also the answer is going to be 0. So basically, see, whenever the expression usually have relational operators, okay, so in that case the answer can be either 0 or 1. Okay, it cannot be different, because relational operator can give us answer as either 0 or 1. It cannot be different, right? So that's why the possible answers of this expression is either 0 or 1. All right, now let's see which one among them is actually correct. Okay, so for that, let me just take you to a small image that I have, and that image will basically indicate all the precedence rules for operators in C++. So let's quickly go to the image and let's see what are the different rules in C++ for the precedence. Okay, so let's see. Alright, so you can see on the screen I have a huge table. Okay, it's a huge table, right? So you can see on the extreme left side, okay, on the, I'll say on the first column, you can see there's a list of operators. Then in the second column there are names of those operators. Okay, and in the third column there is another thing. Okay, I'll talk about it later. Okay, so for now just ignore the third column, or I'll say for now ignore the extreme right one column. Okay, just look at the extreme left two columns. Okay, so the operators which are at very top are having more precedence. Okay, so they have more priority, I will say. Okay, so the precedence table, in the precedence table, so this basically table is called as precedence table. Okay, so the operator which are at very top of this table are having more priority or having more precedence. Let's say in your expression, if you have one operator which is at top of this precedence table, and let's say you have another operation which is at very bottom of this table, then the sub expression which is involving the operator which is at very top of this precedence table will be evaluated first, and then the expression or the sub expression which is having the operator which is at bottom of this table will be evaluated. Okay, so in this way it will work. So let's quickly see what is the order of the operator. So the operator with very high precedence is parenthesis or function call operator. Okay, so parenthesis, I'll say parenthesis just brackets, right? So basically let's say if you are writing 1 plus 2, okay, and if you are giving brackets to it, parenthesis, circular brackets, okay, so the parenthesis is going to have the maximum precedence. Okay, just keep this thing in mind. See, let's say you have 1 plus 2 plus 3, okay, and let's say out of 1 plus 2 plus 3 you are writing 1 plus 2 in parenthesis. So which part will be evaluated first? 1 plus 2 will be evaluated first because it is written in parenthesis. Okay, let's say you have 1 plus 2 into 3. So which and let's say 1 plus 2 you are putting it in the parenthesis. So which part will be evaluated first? 1 plus 2 will be evaluated again. Why? Because it is in parenthesis. So the parenthesis operator has maximum precedence. Okay. But let's say if you are writing expression like this, 1 plus 2 into 3 or multiplication 3, okay, and you are not writing any parenthesis, in that case what will evaluate first? Let's try to figure out from this table. So when you will write 1 plus 2 into 3 and when there will be no parenthesis, in that case, see, we have two operators involved, 1 plus 2 into 3. So we have two operators, one is plus and another one is multiplication. So if you see, the multiplication operator is over here in row number 3, and plus operator or addition operator is in row number 4. Okay, so which operator is having more precedence? Multiplication operator is having more precedence as compared to addition operator. So which part of the expression will be evaluated first? So the part of the expression which will be evaluated first is going to be 2 into 3. So 2 into 3 is going to be 6, and then 1 plus 6 will be evaluated, and the answer of the expression we will get as 7, right? But if you are putting parentheses around 1 plus 2, then which part will be evaluated first? 1 plus 2 will be evaluated first if you are enclosing them in the parentheses. Why? Because parenthesis is having maximum precedence, the highest precedence. You can see parenthesis is written in row number 1. Okay, so the parenthesis is having highest precedence. So whenever you feel that this part of the expression I want to evaluate first, then you can put that part of the expression in parentheses, and that part will be evaluated very first because the parenthesis has the maximum precedence. Okay, so I hope now you are very clear with the basic idea about the precedence table. So let's quickly go through this precedence table. So the maximum precedence is with parenthesis. See, we don't know about what is the function call operator, okay, and we haven't discussed about it right now, but when we will discuss about the function topic in C++, I'm going to tell you what is this function call operators. Right now don't worry about it, but just remember that the function call operator along with parentheses has maximum precedence, okay, and the function call operator looks exact similar to the parentheses, okay, that's why it is having, I'll say, maximum precedence, okay. Then we have post increment and post decrement. So post increment and post decrement also have very high precedence, okay. Then, so this is row number 1. So these two operators are having the maximum precedence. Then the next set of operators which are also having the greater precedence. See, the when I'm coming down in the table, the precedence is going to decrease, okay. So down the table the precedence is going to decrease, okay. So plus plus minus minus, then we have plus minus, this is unary plus and minus. Then we have negation operator, not operator, bitwise complement you can call it as. Then you have address of operator and size of operator. You can see all these operators are, I'll say, unary operators, okay. So it is pre-increment, pre-decrement, this is also unary. Then we have unary plus, unary minus, then we have not operator, bitwise complement. All these unary operators are having, I will say, a good amount of precedence, okay. After parentheses and post increment and decrement, these set of operators are having the next, I will say, highest precedence, right. Then we have multiplication, division and modulus. These are also having highest precedence, okay. Then we have plus minus, then we have left shift, right shift, bitwise left shift, right shift. Then we have relational operators which are less than, equal to, greater than and greater than, equal to. Then we have next category of the relational operator, equal to, not equal to. Then we have bitwise and, bitwise XOR, bitwise OR. Then we have logical and, then we have logical OR. Then we have ternary operator, which is conditional operator, question mark, colon. And then finally we have assignment operator. So which operator is having the least precedence? Assignment operator will have the least precedence, okay. Which operator is having highest precedence? Parenthesis will have the highest precedence. Let's say you have an expression in which there are two operators, one is plus and another one is multiplication. Then which one is having highest precedence? Multiplication is having highest precedence, because you can see multiplication is one row above plus, okay. So whatever is one row or more than one row above another operator, that operator is going to have more precedence, okay. Similarly, bitwise and operator is having less precedence as compared to greater than operator. You can see over here, see, greater than operator is two rows above and bitwise and, right. So bitwise and is having less precedence as compared to greater than operator, okay. So if I will come back to the whiteboard, and if I will ask you what is the correct answer of I'll say the second sub expression. Just try to tell me what is the correct answer of the second sub expression right now. So in the second sub expression you can see there are two operators, one is bitwise and the another one is greater than. So you can see the greater than operator is having more precedence as compared to bitwise and operator. So 3 greater than 1, this part will be evaluated first, okay. So what will be the answer of 3 greater than 1? The answer of 3 greater than 1 is going to be 1, okay. And then 2 and 1, what is going to be the answer of 2 and 1? The answer of 2 and 1 is going to be 0, right. So that's why the correct answer of this sub expression is going to be 0, okay. Similarly, just try to answer what is the correct answer of the first sub expression. The correct answer of the first sub expression is 15, because 2 into 6 is going to be evaluated first, because multiplication is having more precedence as compared to plus, alright. And then we'll see what is going to be the correct answer for the third sub expression. So we'll just again come back to our precedence table. So you can see in the precedence table, just try to find the operator that we have in the expression. So we have equal to, okay, this is one set of operator that we have, OR operator, and then we have AND operator. Okay, so which operator is having maximum precedence? Equal to is having maximum precedence. So all the sub expression which are containing equal to, they will be evaluated first. Okay, so all the sub expression like 3 equal to 2, then 2 equal to 1, whatever sub expression we had in that expression, they will be evaluated first. Now once those sub expression will be evaluated, then we have another set of operators, that is and or. So out of and or, which operator is having maximum precedence? Logical and is having maximum precedence as compared to logical or operator. Okay, so basically the sub expression which is containing logical and operator will be evaluated first. Okay, so if we will go with this logic, let's see what is the correct answer of this code, or what is the correct answer of the third sub expression. Let's see. Okay, so this is or, right? Okay, so these operators are having highest precedence, so these will be evaluated first. So 3 equal to 3, what is the answer? 1. Then or 1 equal to 0, what is the answer? 1 equal to 0, 0, because 1 is not 0. Then and 2 equal to 2, what is the answer? 1, because 2 is equal to 2. So the expression will now look like this after evaluating equal to, because that was having the maximum precedence. Now we have two operators still in the expression, one is or and another one is and. Now which one among two is having maximum precedence? The and operator is having maximum precedence. So if you see the precedence table again, you will see that the and operator, okay, so from bottom you can see the and operator, logical and operator is on the 4th place, okay, from the bottom, and the logical or operator is from the 3rd place from the bottom. So the logical or operator is having less precedence as compared to logical and operator. Always remember, the operator which is at the top is having more precedence, and the operator which is at bottom is going to have lowest precedence. So in our case, the logical or operator is having low precedence as compared to logical and. So what will happen? This part of the sub expression will get evaluated first. So 0 and 1, what is going to be the answer? 0 and 1. Answer of this sub expression is going to be 0, right? And finally 1 or 0, what is going to be the answer of 1 or 0? The answer of 1 or 0 is going to be 1. So the correct answer of this sub expression is 1. Okay, so I hope now you have got how we can evaluate the expression when there are multiple operators involved. Okay, so you just have to keep this precedence table in mind, and then you can literally answer any expression. Okay, so let's quickly revise our precedence table. Let's see the order of the precedence table. So at first we have parenthesis, then we have set of unary operators which are plus plus minus minus, unary plus unary minus, then not operator, then bitwise complement operator, then address of operator, then size of operator. These are having the maximum precedence. Then we have multiplication, division, modulus, then we have addition and subtraction, then we have left shift, right shift, bitwise left shift, right shift, then we have less than equal to, greater than equal to, and greater than. Okay, then we have equal to and not equal to. Okay, then we have bitwise and bitwise or, bitwise XOR. Okay, then we have bitwise not bitwise, then we have logical and then we have logical or, then ternary operator which is conditional operator, and finally we have set of assignment operator. Okay, so this is the way, or this is the precedence level of the operators in C++. So I hope you will keep this in mind. It's not very difficult to digest or to keep in mind. You just see this table once, and I know for sure that you will have this order in your mind. Okay, and when you will become experienced, I mean when you will start coding, and when you will get a good amount of experience, then you will have this in your mind like implicitly. Okay, so you don't have to care too much about all these things. Okay, so it's just for our information how this precedence and all that stuff work.